Hello, I welcome you all. The problem reads a 0.2 kg ball is blown through the smooth vertical circular tube whose shape is defined by r equal to 0.6 sine theta, where theta is in radians. If theta is equal to pi t squared rads, where t is in seconds, determine the magnitude of force F exerted by the blower on the ball when t is equal to 0.5 seconds. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. Let's draw the free body diagram. Again, let's remind ourselves this is smooth, therefore no friction. Okay, no friction. Right. So let's draw so we have a blower here, and blower exerts a force on this ball. We are being asked to determine the magnitude of F. So this ball, and since this path where the ball is moving is curved, there's going to be a point where this ball is in contact with the inner surfaces of this particular pipe, and as a result we are going to have some normal force. So let's assume somewhere there it is in contact with that surface. So let's draw the tangent line. Let's draw the tangent line to that point. Okay, not good enough. Okay, this is not good enough. Maybe we make it like so. All right, let's try and move this closer. Oh no. Okay, maybe something like so. Right, I think this is good enough. Right, so that is the tangent line. That's the tangent line there. So we are going to have some normal force at this point. This is perpendicular to the tangent line. Okay, something like so. So this is our normal force N. This is our normal force N. Alright, so let's extend this, the radial coordinate, something like so. Okay, so this is our radial coordinate, and this one here is going to be equal to our normal. Alright, so we are going to have some components of this normal force. One component will be along this direction, and another component will be along this direction. Alright, let's call this the angle alpha, and then this one here we call it psi, right? Okay, what else do we have here? We do have the weight of the ball. This is the weight, this is W, and then this weight we are going to have some components also. We'll have components along this direction. Okay, we'll have components along this direction there. Okay, and another component in this direction. Alright, and then we do have this the force. So this one here we know it is theta. This is theta, All right, so this is our theta here. So if this is theta, then this one here is theta, right? Okay. And if that is theta, then it means this one here is theta, right? So we have this one which is going to be equal to W cos theta, and this one is W sine theta. Right. Then we do have another force component of F. So we are going to have F in this direction and another component in that direction. Right, I didn't label this. So this is our arrow, coordinate arrow, and this is our coordinate theta. So this one becomes F cos theta. This one is F sine theta. Okay, let me just write this one. I'll write it this side. This is F sine theta. All right. Do we have everything? I think so now. We are good to go. We are good to go. This one here we said this one is n cos alpha, and this one is n sine alpha. Okay. All right, this one we don't have, we can just write it. You can say this is n cos alpha, n cos alpha, and this is n sine alpha. All right. So we can start writing down the equations. Maybe before we do that, let's write down, let's work out values of AR as well as A theta. So let's start with finding what R dot and R double dot is. Our R we've been told is equal to 0.6 sine theta. Therefore, R dot is just going to be equal to 0.6 theta dot. This R dot is dr dt, okay, or derivative of R with respect to time. So cos theta, and then R double dot, we are going to use product rule. So we have we start with one function, we make one constant, the other one constant, we hold it constant, and the other one cos will turn into negative once we work it out. So it will be theta dot squared sine theta, like so. Okay, so let's find what theta is. Let's find what theta dot is. Theta pi t squared. Therefore, theta dot will just be equal to 2 pi t, and theta double dot is just equal to 2 pi. Great. So now let's work out all this stuff at t equal to 0.5. So we know that theta at t equal to 0.5, this just is equal to, feed it in there, where is it? This one here just becomes 0.25 pi. So converting this, right, 0.5 squared, right? Okay, so let's convert this to radians, to degrees. So 0.25 pi rads times 180 degrees divided by pi radians. Okay, so we know that this and this will cancel, and therefore 0.25, which is a quarter, 0.25, right? That's a quarter of 180, so this just gives us 45 degrees. Therefore theta is equal to 45 degrees. Again, you can work with radians or degrees, it's really up to you. So let's find what r is quickly. So our r is just going to be equal to this r here. Okay, our r is just equal to, that is at theta equal to 45 degrees. Our r is just going to be equal to 0.6 sine 45, and this is 0.4243, and then our r dot is just going to be equal to r at theta equal to 45. This is just going to be equal to what do we get? R dot plus 0.6. Let me find this in advance. I'll need theta dot at t equal to 0.5 is just equal to theta dot is just equal to pi. Okay, therefore r dot is 0.6 by pi by cos 45, and we have a 1.33. Okay, then r double dot at theta equal to 45, this is just equal to theta double dot, so we have 2 pi cos 45 minus theta dot squared. Theta dot we said is just pi squared sine 45, and times 0.6. So this is minus 1.52. Okay, what else? I think this is about it. We found r dot and everything else. Okay, so let's find AR. AR is just equal to r double dot minus r theta dot squared. So we have everything else, therefore AR will just be equal to r double dot is minus 1.52, and minus our r. What is our r? Our r is 0.4243 times theta dot is pi squared. Alright, so this we find is a minus 5.71. Okay, and then a theta, this is the acceleration in theta direction. This is just r double dot. Okay, r double dot, sorry, r double dot plus 2r dot theta dot. Therefore, if we were to work out this, our r is 0.2.3 times theta double dot is 2 by 2 pi plus 2 r dot is 1.33, theta dot is pi. Okay, pi. So what do we get? We get 11.02. So we have everything that we need. We can apply the equations now quickly. We can apply the equations quickly. So what do we do now? So we'll say summation of forces in the r direction going in this direction being our reference. This is just equal to I didn't show the directions. Let me show. So we do have our kinetic diagram in that direction and this one in this direction, like so. Alright, so this is our m a theta, this is our m a r. Right, so this is just equal to m a r. Okay, and what do we have in that direction? We do have f sine, and before we find this, okay, it's fine, sine phi minus n cos alpha and minus w sine theta equal to MAR. Let's find what psi is. Psi, so this one we know that tan psi is just equal to r d theta. Okay, and then our d theta is just equal to r there, so this is just 0.6 cos theta. Alright, so dividing the two, so we have tan psi is just equal to r is 0.6 sine theta divided by 0.6 cos theta. Therefore, tan psi is just equal to tan theta. So psi is just equal to theta, okay, which is just equal to 45 degrees. Great. So let's finish off this. So we'll have f there sine 45 minus n and then our alpha is just equal to 90 minus psi. Therefore alpha is just equal to 45 also. So this just becomes cos 45 minus mg sine 45 equal to m by ar, so minus 5.71 m. So that's one equation. Let's work out the other equation. Summation of forces in the theta direction going up being our reference positive, and this is just equal to m a theta. Okay, so we have f cos theta, okay, minus n sine alpha minus w cos theta equal to m a theta. So this becomes f cos 45 minus n sine 45 minus mg cos 45 equal to 11.02 m. So let's solve the two equations. We can solve them simultaneously. So I'll just copy them. I'm just going to copy this. I bring it here somewhere there like so. And I copy this. I bring it somewhere there like so. So we have two equations that we can solve simultaneously, which I'll do. So there we go. There we go. So I'll just let me check them again. This is minus. Where is my N? So summation of forces, we have F. N is positive, N is positive. In this equation, N is positive, right? It's going up. And then this is minus alone. And also there, W is minus, right? There we have F sine 45, N is negative, and mg, right, like this. So this one here is positive. So let's add them. So let's do the adding. So here we'll have F sine 45, that's plus F cos 45. Then this part goes, this and this goes. Then there will have minus 0.2 by 9.81 sine 45 minus 0.2 by 9.81 cos 45. Okay, what else do we have? Alright, and this is just going to be equal to minus 5.71 times 0.2, that's the mass, plus 11.02 times 0.2 kg. So making F subject of the formula, this will just give us, we want to find F, right? Determine the magnitude of F. So let's work out this. So we have 0.2 by 9.81 sine 45. Since sine 45 and cos 45 are the same, you can multiply by 2, take it outside, positive, then minus 5.71 by 0.2 plus 11.02 by 0.2. Okay, and then divided by just 2 sine 45. Alright, so we have F, which is just equal to 2.71 newtons. Okay, so this is the value of F. You can go ahead and check out the value of N, but that was not part and parcel of the problem. Right, so we found F, and I guess we are done with this particular video. And if this video was helpful, give me a thumbs up, like my video, consider subscribing and sharing my channel. Bye bye, and see you in my next screencast.